Yeah, we'll see this question which is asked in 1993 paper. Number of tracks per recording surface is given, which is 200. Remember it. Disk rotation speed is 2400 rotations per minute. Now the track storage capacity is given, which is 62,500 bits. You remember? Now the rotational latency of this device is p milliseconds. So, and of course, average rotational latency is p milliseconds and data transfer rate is q bits per second. We have to identify p value and q value. That means I want to find out average rotational latency, second one data transfer rate. So what is the average rotational latency? I will tell you. This is your plate. Okay. So this is, let's say, your track, and this is the current sector which you want to read. Okay. This is the data you want to read. Now initially this read write head will be located on the appropriate track, correct? Now if your fate is good, then the track will directly go to the data. But sometimes what happens, if your data is far away from this read write head's pointer, then probably we have to rotate the plate. We know that, right? So we have to rotate the plate so that the sector will come to, the data sector will come to the right place. That means it should come to the read write head. How much time it will take? So that is nothing but exact rotational latency. But we cannot find out exact rotational latency because it depends on the distance between this data and your pointer. So the distance between this pointer and data is highly variable. It may be 0 if already the sector is on, your read write head is under this, on top of this data. In the worst case, maybe it is here, so that complete rotation is required. We have to completely rotate the plate to get it, right? Easily we can understand these, distances and all, right? Easily you can understand that. In the worst case, it will take one rotational latency. That's what people realized. Since it is variable between 0 to 1 rotational latency, anything can happen. Then using some probability, so I am assuming that every case is equally likely, then average case will become half of, because values are 0 to 1 rotational latency, then we can say average as half rotational latency. From now onwards, because exact calculation we cannot do, then the rotational latency we take, that means average rotational latency will take as half of the rotational latency. Sir, what is one rotational latency? How to calculate it? We will see. We will see exactly one rotational latency. One rotational latency is nothing but the time required to the time required for a disk to rotate exactly one, complete one iteration. We will see that. We have given, this rotation speed. What is that? 2400 rotations per minute. So we'll ask directly that speed. My dear, disk rotation speed, what does it mean? What is 2400 means? That means within 1 minute the disk can rotate 2400 times. That means 2400 rotations per minute. Minute means 60 seconds. But I would like to find out one rotational delay, correct? So that's why one rotation takes how much time? That would be, see, remember one thing, this is direct proportionate, correct? 2400 60 seconds. One rotation also depends on the number of rotations. That means, so for 2400 rotations 60 seconds, for one rotation it will be less, correct? So that's why among these two, which one is less? 1. 1 will be on numerator, 2400 will be denominator. See, generally in my childhood I have learned this trick. What is that? Is whenever you have this kind of question, 2400 rotation 60 seconds, one rotation how much, then you ask this question to these values. For 2400 rotations, if you take 60 seconds, for one rotation it takes how much time? Lesser than the these value. That means lesser than or more than this value? Definitely lesser, correct? Because it will be, for 2400 it is 60, for one definitely it is lesser than 60 seconds. Then in these two, which one is least? 1 will come on top, 2400 will come down. If you get the keyword most in when you are asking this question, if the keyword is like this, 2400 rotation 60 seconds, one rotation takes more than 60 seconds, then more means among these two which one is highest? 2400 will come on top, 1 will come on bottom. That is the way. So generally you can remember this kind of formula, 1 by 2400 into 60 seconds, right? So 60 40 is the, it would be 1 by 40 seconds. That is nothing but 1000 milliseconds is nothing but 1 second. Remember, I am converting 1 second into 1000 millisecond by 40. Then if you simplify it, you get 25 millisecond, remember it. Finally, one rotational latency is 25 millisecond, but we would like to find out half of the rotational latency because average is half, right? So half of the 25, which is nothing but 12.5 millisecond. From now onwards, whenever the question is about average rotational latency, simply the formula is half of the full rotational latency, which is nothing but half of the 25 here, which is 12.5 milliseconds. Remember it. Now, the second question is data transfer rate. So how to understand data transfer rate, I will tell you. This is your disk. Okay, data transfer rate comes into the picture after locating the data. So assume that, let's say, your read write head comes to the right place, so the data is already available. Okay, so after that, how much time further you require to transfer the data? So it depends, most of the times it depends on the speed of the disk, right? In the problem they have given only speed of the disk, right? No other parameters. Then using this we can solve this problem like this. See, if only this disk rotation speed limits us, then one in what is the rotational speed for one rotation? How much time it will take? So one rotation takes, already we have seen 25 millisecond, correct? So that means what? So within 25 millisecond of time, your disk will be completely rotated. See, whenever you want to take the data, first of all disk has to be rotated, correct? See, this is your read write head. While rotating we are taking the data, then how fast that rotation can take place? With the same speed we can take the data. That is what the idea. Okay, so since within 25 millisecond it can completely rotate, if it completely rotates, then entire track I can read. So what is the track capacity? That's why track capacity is important. The track storage capacity is 62,500 bits. Now I can say like this: to read 62,500 bits, okay, this disk has to be rotated for one full rotation. So one full rotation time is 25 millisecond. So this is the your data transfer speed, right? So 62,500 per 25 millisecond. Then for 1 second, how many bits we can take, right? So if you simplify it, you might get this answer like this. So again, same question for 25 millisecond, 62,500 bits, but I have 1 second means what? A bigger number, right? 1000 milliseconds. Within 1000 milliseconds, how many bits you can transfer? More. So in these two, which one is more? 1000. That's why 1000 will come on top, 25 will come on bottom into 62,500 bits. Let us simplify it. 25 fours are 100. It would be 40, right? So 40 into 62,500 bits per second. This is the speed. Okay. The question is also q bits per second. Then q is nothing but 40 into 62,500. You can simplify it.